So now, having done the anatomy of the different layers of the lens, or the eye rather, not the lens, uh, except the inner layer of the eye, right? The inner layer of the eye, that is the retina, that is the only part's anatomy that I have not covered yet on my channel. And the reason for that is the anatomy of the retina will be covered when I talk about the retina as a whole unit. So I won't be dealing with the anatomy of the retina as a separate video. I will deal with it in a separate video, but later. Okay. Right now, we focus our attention towards the anatomy of another structure within our human eye, that is the lens. Okay. Now, lens, or the lens in the eye that we have, it's a structure that we have seen repeatedly in our previous videos. If I can just go back to some previous videos where I had shown the different structures here. As you can see, this was when we were talking about the middle layer of the eye, and this is this image over here. This is actually what? This is actually a transverse section that had been taken of the eye, and then we are looking at it from above, right? Only to appreciate the different layers of the eye. Now, as you can see over here, this over here in the middle, as it is labeled, is the lens. So the lens of the eye, what exactly is the function of the lens? Why do we even have a lens in the eye? So it's very simple actually. What is the function of the eye as a whole? To see things, right? To form images. It is a part of our sense organ, right? We know all this. Now, from our discussion on accommodation, near reflex in our previous video, we also know the fact that to form images of an object, the eye needs to focus the light rays traveling from said object onto the retina. Retina is the innermost over here. You can see the yellow portion, the yellow layer over here, that is the retina. The retina is the innermost neurosensory layer of the eye. So that is the layer over which impulses are created. They travel via the neurons, and the optic nerve travel to the brain. Where in the brain, how all of this happens, we'll talk about it later. Then from the brain, again, impulses are carried over, and in the brain itself, these impulses or sensations are translated, you might say, as an image. Okay, so basically, in a very layman term, I would say in a very layman way, I have explained to you how images are formed. Obviously, we'll see to this in a lot more detail later. Now, the crux of this entire discussion is the fact that we need, by hook or crook, to converge the light rays traveling from an object onto the retina. And we have seen how this happens to some extent when we were talking about accommodation and near reflex. So, our eyes need structures which can converge the light rays. One of those structures, focus on what I'm saying here, one of those structures is the lens in the eye. So, just like we wear glasses or spectacles, whatever you might call them, these glasses or spectacles, what are their jobs exactly? Their job is similar to the lens that we have in our eye, because the glasses or spectacles also have lens, right? So what exactly is their function? Their function is to either converge or diverge, depending on what kind of glasses you're wearing, the light rays from objects, so that ultimately the light rays can fall on the retina. See, the end game is always to form an image on the retina. If the image is forming in front of the retina, if the image is forming behind the retina, in any of these scenarios, we will get blurred images. Okay, we will see to this later when we talk about optics. So, now that we know that the lens is one of the refractive structures within our eye, we know what exactly the function of the lens is. So, based on that, the first thing that we know, the first thing that we can very easily deduce from all the discussion that we had as of now, is the fact that for light rays to be converged by the lens needs to be transparent. because light rays need to travel through it. Obviously, light rays cannot travel through an opaque subject, obviously. Second thing, and this is something that we had talked about when we initially started our eye anatomy videos, that anything which is concerned with light traveling through it cannot have a blood supply. What am I exactly drawing this reference from? If you do not understand what I'm talking about, see my video on cornea. Even if you don't, let me just explain to you. See, lens, cornea, these structures are transparent. If blood supply was present for these structures, then the blood vessels would have been running over these structures, and then would the transparency have been maintained? Obviously not. The transparency could not have been maintained if the blood supply was present. Blood vessels would have been running over these structures, right? So that is why, just like the cornea, lens is also avascular. Okay. Now, what about the nerve supply? Now, this is something where lens and cornea are a little different. We know that cornea has a nerve supply. Cornea has innervation. What exactly was that? TON, if you can remember. Okay. Nasociliary nerve, ophthalmic branch of the trigeminal branch of the trigeminal nerve. Trigeminal nerve, ophthalmic branch, nasociliary nerve. This is the innervation of the cornea. But what about the lens? Does the lens have any nerve supply? No. This is where it is a little different. So no innervation as far as the lens is concerned. Done. Now, having said that, let's focus our attention towards this image that I have drawn over here. This is supposed to be an illustration of how a lens is situated. So as you can see, I have already labeled anterior and posterior. So this side over here is the anterior surface, and this side over here is the posterior surface of the lens. Now, the first thing that I would like to draw your attention towards the fact is this dotted line that is running through the center of the lens, dividing it into two equal halves. This dotted line is not actually present in the lens. It is rather an imaginary line that we have drawn. This dotted line that divides the lens into two equal halves is called equator. So it is exactly like our planet Earth. So in our planet Earth also, when we study geography, we have these imaginary lines we call latitudes and longitudes that we use to demarcate the Earth, to use coordinates and stuff. So one of those latitudes was what? Equator. Equator was the horizontal latitude which divides the Earth into two equal hemispheres, the northern and the southern hemisphere. So exactly like that, the equator of the lens is dividing the lens into two equal halves, one anterior and one posterior. Now, this anterior surface of the lens, although it is not very deducible from this image, but I would like you all to make a mental note of the fact that the anterior surface is flatter compared to the posterior surface. The posterior surface of the lens is actually more curved. Okay, this is less curved and this is more curved. This is more curved, this is less curved. What do I mean by curved over here? Another term that we can use instead of curved is the fact that this is convex, or rather this is less convex and this is more convex, right? We know that convex is this and concave is this. This is a concave lens, this is a convex lens, or rather this is a biconvex, because both the surfaces are convex, and this is a biconcave. Okay, just to revise what convex and concave mean so that you don't get confused. Now, having understood what the equator is, let's get on a fact about the equator. That is, the diameter of the lens, that is the equator's length itself, is 10 mm, 10 millimeters. Okay, so diameter of the lens, we can say diameter just like the diameter of a circle, just like that the diameter of the lens, that is the equator, right? That is equal to 10 millimeters. Done. Now, what exactly is the position of the lens within the eye. So if I take you back to that picture that I was showing you before over here, you can see that the lens is situated at a particular place within the eye. We were talking about the different structures of the eye in this video, or rather in this slide, in this image, and you can see that the lens is placed in between the ciliary body, located in between the ciliary zonules, and the ciliary body. So this fossa that the lens is placed within in the eye is given a special name. The special name given to that is the patellar fossa. So let me quickly give it patellar fossa. So if you did not understand what patellar fossa is, let me just make it very clear to you. See, if this is the lens, this over here is the ciliary body, these were the ciliary zonules, right? Now this over here, this fossa that the lens is placed within, this is called the patellar fossa. Okay, this is the ciliary body. Okay, the fossa that the lens is situated within is the patellar fossa. Now another fact about the lens, the refractive power of the lens is actually between plus 16 diopters to plus 19 diopters. Plus 16 to plus 19 diopters. Diopters, as you know, is the unit of power. Diopter is nothing but power is what? I had said this in my previous video as well, that power is actually 1 by focal length. So diopters is nothing but 1 by meters. So it is meter inverse. Anyways, so diopters, plus 16 to plus 19 diopters is the power of a normal physiological lens. Whereas if we remember correctly from our video on cornea, we had said that the power of the cornea is approximately plus 43 diopters. So this means that the cornea is a much more contributing factor or contributing structure towards the convergence of light rays rather than the lens. So even though the lens, the primary objective of the lens is to converge light rays, but it is merely supplementing what the cornea is doing on a more massive scale. Okay, anyways, even then the lens, credit where it's due, is a very important structure. Now another interesting thing about the lens, as far as its embryogenesis is concerned, is the fact that the lens develops from something called the surface ectoderm. The surface ectoderm. We know ectoderm, mesoderm and endoderm. These are the three, you might say, gestational layers from which the different structures in our body emerge. Surface ectoderm is from where the lens actually develops from. Okay. Another interesting thing about the lens, if I can just draw your attention towards this, is the fact that not everywhere within the lens has the uniform power. The central part of the lens, this over here, this is the central part. So the central part of the lens actually has been found out to have more refractive index. So it means that it has more power than the peripheral part. So the central part's refractive index, if I was to put this into some kind of a comparison, this would be approximately 1.406. That is the refractive index. The refractive index of the central part of the lens is approximately 1.406. And to put this into comparison, this is the peripheral part of the lens, and this has approximately 1.386 as its refractive index. So obviously the central part is more converging and the peripheral part is less converging. Done. Now, having gone through all that, let's now move towards the different structures that are associated with the lens. So as you can see, there is already an image over here, and we are going to see the different structures that are associated with the lens. As you can see, the very first thing that I'm going to do is you can see that this is the lens. Okay, let me very quickly get a separate, yeah. So this over here, this is the lens, right? You can see this. In front of this, over here, we have the cornea. And over here, this is the anterior chamber, right? We know this. This over here, these are all structures that we have already talked about. That is why we're not going into the details of these structures. This over here is the iris, right? See carefully over the lens. This and as well as this, these two structures are the iris. I mean, obviously we can see two over here, but obviously this is a section of the eye. So if you were to think about this in a three-dimensional way, this would be the entire eye. This will be covering the entire lens, right? Think about it. When you look at the mirror, you can visualize or you can recognize the iris. So this over here is the iris. Okay. Behind it is the lens. Okay. Done. Done. Now, iris is part of the middle layer, right? So this over here, this must be the other part of the middle layer, that is the ciliary body. And from the ciliary body, if you can see I'm like zooming in a lot more now. This over here, that black line that is going, that is something going from the ciliary body and attaching towards the lens. So it is basically a structure, or rather structures which hold the ciliary body, or rather which hold the lens to the ciliary body. They are nothing called but the ciliary zonules. Ciliary zonules. Okay. So these are all, I would say, things and structures and I would say images that we have already familiarized ourselves with. Now let's actually deal with structures that we haven't dealt with as of yet. See, behind the lens, what do you have? You have this huge chamber called the posterior segment. So let me first, if you remember, let me very quickly go back to that slide where I had talked about the different segments and chambers. So if you can see over here in the spaces in the eye, I had said that there are three spaces. Number one is between iris and the cornea, that is known as the anterior chamber. Number two is between the lens and the iris, that is called the posterior chamber. Anterior chamber and posterior chamber together make up the anterior segment, whereas the entire space behind the lens is the posterior segment. Okay, posterior segment. This posterior segment houses, or rather contains, what we call to be the vitreous. So this entire structure over here is the vitreous. Here also, here also. Okay, vitreous. Done, done. Now, can you see this space over here? This space between the vitreous and the lens. If I can remove it, then I will be able to show it to you again. Okay, now see. Can you see it now? This space between the lens and the vitreous is called the Berger's space, or the retrolental space, as you can see, the Berger's space, or the retrolental. See, it is nothing difficult. Retro means behind and lental comes from the word lens. So retrolental, behind the lens, there is a space in between the vitreous and the lens called the Berger's space. Okay. Now, what are these red structures over here? These red structures are the points of attachment between the vitreous and the lens. So the Berger's space was the point where the vitreous and the lens were not attached. That is why there was a space or a cavity in between them. But what about the places where they are attached? That is where we say it is attached via a ligament called the Vigart's ligament. So Vigart's ligament is nothing but the attachment between the posterior surface of the lens, attachment between the posterior surface of the lens and vitreous. That's it. So did you understand these two new structures that we have just described over here? The space between, there is a part where the lens and the vitreous are not attached to each other. That is called the Berger's space or the retrolental space. Whereas the places where they are attached to each other, it is known as the Vigart's ligament. Okay? Okay. Now let's come to this big or rather long space or canal, whatever you want to call it, that is running throughout the entire length of the posterior segment through the vitreous. This is actually a canal. Let me actually, you know what? Let me use red over here. Don't get confused between the fact that both the Vigart's ligament over here and this canal that I have just, illustrated with, they are using both red colors. Do not get confused by that. Vigart's ligament is Vigart's ligament. Okay. This canal that is running from the lens up to a structure over here, right? This is actually a structure over here. This is actually nothing but the optic disc. Optic disc. Okay, there is the optic disc present over there. Okay, now don't worry about this space of Martigiani. Don't worry about that. I'll talk about what that space is in a bit. Okay, do not get confused. So what am I talking about? Did you understand what Vigart's ligament is? Did you understand what Berger's space is? Good. Now we are advancing. We talked about, or rather we are talking about, this long canal that is running from the lens up to the optic disc over here. There is a structure over here called the optic disc. What exactly is the optic disc? We'll talk about when we talk about retina. So this long canal is called the Cloquet's canal. The Cloquet's canal. This Cloquet's canal, it runs from, I have said this like 1,000 times now, from the lens to the optic disc. Optic disc. Okay. Now, if it is a canal, then obviously it means there is a hollow space in it. Then there must be a structure running through that space. What is that structure? And that is why I have used a red color over here. That structure is an artery. What artery? The hyaloid artery. So this over here is the hyaloid artery. This hyaloid artery runs through the Cloquet's canal, and what is it running towards? It is running towards the lens. So that means, what is the work of an artery? The work of an artery is to supply, to provide vascular supply to a structure. So hyaloid artery's work, or rather function, is to provide vascular blood supply to the lens. Then what did I just say a few minutes ago? Lens is an avascular structure. If the lens is an avascular structure, then how in the hell is a hyaloid artery, or rather how in the hell is an artery supplying it? What is going on? This is a paradox. I'm contradicting my own self. Actually, I'm not. I'm not contradicting myself, because all of these structures that we are talking about, or rather at least this structure, that is the hyaloid artery and the Cloquet's canal, these are structures which are present only during our embryogenesis and a few months of gestation. When we grow, these structures disappear. So this means that during embryogenesis, when the embryo is being formed, these structures are present. Okay, the hyaloid artery, the Cloquet's canal, they are present. But by 8 months of gestation, they disappear. They will disappear. Okay, understood? So lens is an avascular structure, except in its embryogenic state. When it's in an embryo, when it is developing during gestational 8 months, it is not avascular, it is supplied by the hyaloid artery. Hyaloid artery runs from where to where? It runs from the optic disc up to the lens. What is the structure that it runs in? It runs within the Cloquet's canal. Okay, okay. Now, there are two important pathologies which actually are associated with the fact that by 8 months of gestation, both the Cloquet's canal and the hyaloid artery should disappear. Mind the word should. Why? Because if they persist, then that is a pathology, that is an abnormality. What is the abnormality? If they persist, if who persist? If the hyaloid artery or the Cloquet's canal, if they persist, then they can lead to two things. Number one, something called Mittendorf dots. Mittendorf dots. This is the name of the anomaly. What exactly is this? This is nothing but, if I can just go back to my white. Sorry. This is nothing but the remnant of the hyaloid artery on the posterior surface of the lens. So remember that the hyaloid artery was running from the optic disc up to the posterior surface of the lens. So if the entirety of the hyaloid artery has disappeared, but some part of it remains within the posterior surface of the lens, then that anomaly is called Mittendorf dots. What is the other anomaly? The other anomaly is something called Bergmeister papilla. Bergmeister's papillae. What are these exactly? Another anomaly which occurs when, if the hyaloid artery's remnant is present at the optic disc. So it is exactly the opposite. It is exactly the opposite. So basically, if this is the lens and this is the optic disc and this over here is the hyaloid artery, this is how it is traveling. By 8 months, this entire thing should disappear. But if only this much disappears and some part of it remains, then that is called Mittendorf dots, posterior surface of the lens. On the contrary, if this entire thing disappears, but this much remains, then that is called Bergmeister's papillae. Okay? Remnant at the optic disc is Bergmeister's papillae. Remnant of the hyaloid artery at the posterior surface of the lens is the Mittendorf dots. Done? Done. And by what time does the hyaloid artery disappear? It disappears by 8 months of gestation. Okay? Okay. Now let's go back to that one structure that I had said we will talk about later. This space of Martegiani. Now, space of Martegiani is actually the space between the vitreous and the retina. So if I just, okay, I already have the eraser selected. Let me just do this. See, this is the space of Martegiani. So what exactly is present in front of this space? As you can see, this is the vitreous. The vitreous chamber cavity is present. And we have just talked about the fact that the optic disc is also present over here. So basically, the optic disc is present in which layer of the eye? The optic disc is present in the retina. Right? That is why I said that we will talk about the optic disc in a lot more detail when we talk about retina. So the optic disc is present in the retina. Retina. Okay? So the space between the retina and the vitreous at the optic disc is called the space of Martegiani. Martegiani, as you can see. Okay? Okay. So it's not really a very important space, so that's why we are not going to go into the details of that. Now let's go about and talk about another interesting anatomical perspective as far as the lens and its attachments are concerned. So over here you can see that I have drawn an image. Now if you have been paying attention and been watching my videos, then you can already kind of understand what these structures are. Over here, okay, let me label all of these. This over here, these are the ciliary body. This entire thing is the ciliary body, and these over here are the ciliary processes. This, and this ciliary processes. Okay, and this entire thing is a ciliary body. Okay, now from the ciliary processes we know these thread-like structures, they are called the ciliary zonules. Ciliary zonules are very interesting. We have given special names to some ciliary zonules. What exactly are those special names? See, before we talk about those ciliary zonules, let's talk about another structure that we know from our previous discussion, or rather from the discussion that we had just 5 minutes ago. This imaginary equator, we cannot forget about this. We have already talked about this in this video, right? This imaginary line, this is the equator. Okay, and so obviously this is the lens. Goes without saying. Okay, this over here is the anterior side, this over here is the posterior side. So now the stage is set. We can see very interestingly these green structures, these green thread-like structures, these are ciliary zonules. I'm not labeling them right now because we are going to label them in a special way. What is the special way? See, this over here, the anterior-most ciliary zonule, from which I have drawn an arrow, this ciliary zonule, if you look at it very closely, if you look at its attachment, you can see that it is in front of the equator. The anterior-most ciliary zonule, from which I have drawn an arrow, this green structure, this over here, this structure. This structure, if you can see, this is the equator. This is the equator, right? You can see that this is in front of the equator. That is why this is a ciliary zonule in front of the equator, and that is why this has been given a special name called pre-equatorial zonule. Pre-equatorial zonule. Pre-equatorial zonule. Pre means in front, equatorial because equators in front, and zonule because it is a ciliary zonule. Done. Just like that, you can see that this one over here, this ciliary zonule is behind the equator. This is called the post-equatorial zonule. The post-equatorial zonule. I'm abbreviating it. You can understand, I hope. Post-equatorial zonule. Okay. Then what is the posterior-most zonule known as? The posterior-most zonule has been given a very special name, even though it is also a post-equatorial zonule, but it has been given another special name called the hyaloid zonule. The hyaloid zonules. Okay. So we have the pre-equatorial zonules, which are the anterior-most, the post-equatorial zonule, and the hyaloid zonule. Okay. Now, why have we given these special names? That is because in between these zonules are present certain spaces that we need to know about. What are these spaces that I'm talking about? See, in between, let me quickly choose a different color over here. Suppose, okay. So in between these two spaces, or rather in between these two zonules, can you see this space over here? That is the in between the pre-equatorial and the post-equatorial zonule. This space over here, this is known as something called the Canal of Hanover. The Canal of Hanover. So the Canal of Hanover is the space between the pre and the post-equatorial zonule, whereas the space between the post-equatorial zonule and the hyaloid zonules, this space over here is known as the canal of Petit. Canal of Petit. So, canal of Hanover is the anterior space and canal of Petit is the posterior space. What are the structures which bind the canal of Hanover? The canal of Hanover is bound by the pre-equatorial zonules and the post-equatorial zonules, whereas the canal of Petit is bound by the post-equatorial zonules and the hyaloid zonules. As simple as that. Understood? Understood. So this was in a little bit more detail the structures associated with the lens. Now, as far as the lens itself is concerned, let's take a very quick deep dive into the layers of the lens. So now we will talk about the layers of the lens. What exactly do we mean by the layers of the lens? See, as of now, what we were discussing were the different structures associated with the lens, but we hadn't gone into the details of the lens as a structure itself. The lens as a structure, what is its composition? How is it made? What are the different layers which make the lens itself? That is what we are going to talk about here. It's very simple. See, you can already see that the lens is made of different layers. And what exactly does this remind us of immediately? I can speak for myself. This immediately reminds me of an onion. Yes, the different layers of an onion. Just like an onion has different layers which come peeling off, the layers of the lens also are similar to each other. So, what exactly? Let's start very simple. What is the outermost layer of the lens? The outermost layer of the lens is something called the capsule. Let's name the layers and let's immediately over here, as you can see, this entire black lining around the lens, this is the capsule. Okay. Now, capsule is a structure, or rather a layer of the lens, which is surprisingly continuous throughout the lens. It is continuous throughout the lens. What does this mean? This means that there is no part of the lens which is not bound by the capsule. This will be interesting to know, or rather this will be very advantageous to know when we talk about the next layer of the lens. Okay, so just bear with me right now. So the outermost layer of the lens, that is the capsule, is continuous throughout. Now, just like we had talked about in cornea, the different layers of the cornea, or rather the different parts of the cornea, we had also talked about the thickness of the cornea, and we had said that the cornea is not thick uniformly. So just like that, the lens capsule is also not uniformly thick all throughout. So there are parts of the lens capsule where it is very thick, parts where it's very thin. So let's very quickly then go throughout the different parts. What exactly, or rather where exactly, is the lens capsule the thickest? The lens capsule is thickest at a part of the lens called the posterior pre-equatorial zone. Posterior pre-equatorial zone. What exactly is that? See, although in this image, this is actually not exactly drawn accurately, I would say, because over here you can see somewhere over here. So let me just make this correction myself, I guess. See, over here the lens capsule will be the thickest. What is this part? This part is the posterior part. First of all, understand that this is the posterior. This is the posterior part. Okay. Now, very quickly, let's orient ourselves. This is the anterior, this is the posterior, right? We can see it's already labeled. So the equator will be running somewhat like this. Equator will be running somewhat like this, right? So now this area that I've just drawn over here, this area is in the posterior side of the lens and it is just behind the equator. So it is very close to the equator. That is why it is the posterior pre-equatorial zone. So just like the posterior pre-equatorial zone, there is another part that is the anterior pre-equatorial zone over here. This part over here, this will be the anterior pre-equatorial zone. This over here will be the posterior pre-equatorial zone. Okay, so I'm just drawing the analogy here so that you can understand where exactly is the posterior pre-equatorial zone and where exactly is the anterior pre-equatorial zone. We are more interested with the posterior pre-equatorial zone because posterior pre-equatorial zone is where the lens capsule is the thickest. Okay. Now, another structure that I need to draw your attention towards. This over here, can you see? I'm actually, okay, let me use a different, okay, let me use the green. So this over here, this point of the lens, this part of the lens, where it is almost at the center, it is exactly at the center, but it is at the posterior side. This side is called the posterior pole. Posterior pole. So just like that, there will be an anterior pole over on here. Okay. Anyways, so we talked about the posterior pre-equatorial zone and the anterior pre-equatorial zone, right? So posterior pre-equatorial zone is where the lens capsule is the thickest. Posterior pole on the other hand is where the anterior or the lens capsule is the thinnest. So that is the posterior pole. So both thickest and thinnest at the lens's posterior surface. Thickest at the posterior pre-equatorial zone and thinnest at the posterior pole. Okay. Posterior pole is what? The center of the posterior surface. Done. Now, another interesting thing about the lens capsule is the fact that the lens capsule is actually what? The lens capsule is actually a basement membrane. In fact, very interestingly, the lens capsule is the thickest basement membrane in the entire body. That is how thick the lens's capsule is. It is the thickest basement membrane in the body, and it is made up of type 4 collagen. So the lens capsule, having talked about that, let's move on to the next layer. So as you can see, the lens capsule was this black border line that is surrounding the entire lens in this image. You can see, I hope. Now let's move on to the second layer. The second layer, if you look carefully, it is this blue. This entire blue thing that we have. This layer is the second layer. So what exactly is the second layer? Having shown you this, let's move on to the second layer, and that second layer is known as the epithelium. Actually, more aptly, it is known as the anterior epithelium. So epithelium means epithelial layer. So epithelium, like anywhere else except stratified epithelium, it is a single cell, or rather single layer. Yeah, single cell layer, you might say. It is a single cell layer. Okay. So why are we saying that it is only anterior epithelium? Let me take you back to this picture, then you will understand it very carefully, or rather very quickly, that there is no posterior, let me use a different ink, no posterior epithelium. Can you see? It is barren. There is no blue layer in the posterior side. So actually what happens is, the posterior epithelium, they actually, during embryogenesis, the posterior epithelial cells will elongate to form the primary lens fibers. Okay. So what happened to the posterior epithelial cells? the posterior epithelial cells during embryogenesis, they actually elongate to form the primary lens fibers. So they will form some other part of the lens, they will not remain as epithelial cells, only the anterior epithelial cells remain. Anterior epithelial cells are of two kinds. Number one, the A cells, and number two, the E cells. A cells and E cells. A cells, they are actually present at the proper anterior surface of the lens, and they are concerned with the metabolism of the lens. Metabolism of the lens. E cells, on the other hand, see, A for anterior, E for, yes, equator. They are present at the equatorial zones. They are present at the equatorial zones. And these E cells, they are the ones which form new lens fibers. New lens fibers. Why, or rather how? Because these E cells are capable of mitosis. So A cells are capable of metabolism and E cells are capable of mitosis. So let's go back. See, there are two different kinds of epithelial cells. Let me very quickly draw the distinction for you. Over here, these over here, look at this very carefully. Do you see these which are present strictly at the anterior surface? These epithelial layers, these epithelial cells, these are the A cells. Whereas these over here, they are elongating at the equator. When they are reaching close to the equator, these cells are elongating. Can you see? They are elongating to form lens fibers. So these cells are the E cells. They elongate to form new lens fibers. Whereas these over here are the A cells, which are concerned with metabolism. Okay, done. Now let's talk about the third layer. So the third layer that we have is something which is called the cortex. The cortex. So actually the cortex is just like the capsule, a complete layer. So there is no part in the lens where the cortex is not present. It is present both anteriorly and posteriorly. Unlike which layer? The epithelial layer, which is present only anteriorly and at the equator, not posteriorly. What happened to the posterior equatorials, or rather the posterior epithelial cells? Those posterior epithelial cells during embryogenesis, they've elongated to form new lens fibers, and thus they were lost. Okay. So cortex is actually what we can say to be the lens fiber layer. See, as of now, the capsule, the epithelial cells, they are not lens fibers. I had said that the epithelial cells, or rather the E cells in the epithelium, they elongate and in the future they will form lens fibers. But they themselves are not lens fibers. See, you can see in this picture that the E cells, they are elongating over here. See, over here. They are elongating, but they haven't yet turned into lens fibers. Okay, they will turn into lens fibers. And when they do turn into lens fibers, they will become a part of this white, this layer, this white layer, this entire white layer. Okay, they will become a part of this white layer. And this white layer is the cortex. So cortex is actually the first real lens fiber layer. And as such, if the cortex is being formed by the E cells which are forming lens fibers, that means that the cortex is basically formed by the youngest lens fibers. Because think about it, the E cells are forming the lens fibers and they are becoming part of the cortex. So you form and you become a part. You are formed and you become a part of the cortex. That means you are just born and you become a part of the cortex. That means the youngest lens fibers, they actually form the cortex. Okay. Now let's move on to probably the most important layer, that is the innermost layer called the nucleus. Nucleus, if I can just show you, is this entire thing. So this entire let me quickly show you. Let's use green. This entire thing at the middle, this entire thing that I'm shading with green, this is the nucleus. Okay, now as you can very quickly deduce from this image that the nucleus again has a few layers of its own, but there is nothing to be worried about. See, let me quickly just rub off everything from here, erase everything. So now we will discuss in detail about the nucleus. Okay, forget about everything else, or rather don't forget about everything else, we have already talked about everything else. Okay, we have already talked about everything else, so just pay attention to now only this nucleus part. See, the nucleus again has different layers to it, different structures are forming the nucleus. If you remember, I just said that the cortex is forming the youngest lens fibers. Okay, nucleus on the other hand is formed by the older lens fibers. How? See very, very carefully. When does our lens actually begin to form? See, our lens, let me go back to that slide over there. Yeah, so our lens actually, it begins to form by day 27 of gestation. So at day 27, what exactly is the name of the product of conception? It is the embryo. So when we are an embryo, that is when our lens fibers start forming. The lens starts to form. So the first kind of lens fibers that are formed are named the embryonic lens fibers, or the embryonic fibers. Okay, now as the lens develops more, as the period of gestation progresses, the embryo grows into a fetus, and as such new lens fibers are laid over the embryonic lens fibers, and these new lens fibers are known as the fetal fibers. Okay, the fetal fibers. From fetus, after that the baby is born, and as such the baby is known as an infant. New lens fibers are laid and they are called the infantile fibers. After that, the infant grows into what? An adult? So we have at the end, I don't have space over here, the adult fibers. The adult fibers. So why exactly am I talking about these right now? Because all of these A, B, C, D, embryonic fibers, fetal fibers, infantile fibers and adult fibers, these are all lens fibers. And these are all part of the nucleus. All part of the nucleus. So as you can see, at the very center we have the embryonic nucleus over here. The embryonic nucleus. Why? Because the lens fibers, they start being laid off, or rather they are laid off at the center, and around it newer and newer fibers are laid. So in a way, we can say that the embryonic nucleus is the oldest, and as such known as the primary lens fibers. All the other fibers they are known as secondary lens fibers. So over the embryonic nucleus, the fetal nucleus is laid. Over the fetal nucleus, the infantile nucleus is laid. And over the infantile nucleus, the adult nucleus is laid. And over that, we have the new forming lens fibers, which is the cortex. And over that, the E cells and the A cells of the anterior epithelium. So, from, if you can say, center towards the periphery, we are moving old to young. Right? From old to young. From center towards periphery. Okay? Okay. So, that in a nutshell is all about, I would say, the nucleus. And this is very, very important when we'll talk about the different anomalies of the lens, especially the biggest anomaly, the biggest pathology related to the lens, that is cataract. We will see how all these different anatomical terms, the cortex, nucleus, pre-equatorial, post-equatorial zone, and all of this will come into play over there when we'll talk about the different types of cataracts. So hopefully this video has been of some help to you in understanding or getting a basic overview of the lens anatomy. It is not rocket science, definitely it's not rocket science. In fact, it is a lot easier than a lot of other ophthalmology topics as well. Very easy to understand. Hopefully I have been able to make you understand, and hopefully I've been able to make this somewhat interesting for you. In the next video, we'll talk about probably the metabolism of the lens, and then we'll delve into the different pathologies of the lens and cataract. Thank you, and I'll see you again in the next video. Thank you.